force and motion. So let's start. Which of the following statements is true? Balanced forces always cause a change in motion. No, it does not. Because there are balanced forces, so there are equal forces on both sides, so there's nothing pushing the object. Unbalanced forces do not cause change in motion. Well, it does cause a change in motion because they are not equal, so it will pull. Gravity always causes a change in motion. No. Balanced forces do not cause a change in motion. Yes, because the balance motions are equal, that they do not make any difference of where it is. Oopsies. I forgot to click. Jacob pushed the box of books across the orange floor, and the box moved forward. When the box stopped moving, Jacob rested for a moment. Then he put a force on the box a second time. This time the box moved faster, but faster and farther than the first time. What kind of force did Jacob put on the box the second time? A push with more force. A pull, when they put a pull, it's a bit harder to move. Like when you're pulling, you apply more force, and when you're pushing towards yourself, you apply more force, and when you're pushing, you apply less force towards yourself. A push with less force will make it a bit lesser mover, that's why, and a pull with more force, still a push is better. Amazing. The picture below is of a Newton's cradle. Observe the motion of the 5 balls. Well, only 2 balls are moving. I observed that. What is the pattern of the ball's motion? Each ball's motion is the same as the others. No, these 3 balls in the middle are not even moving. These 3. 1, 2, and 3. And these 2 are moving. Each ball direction is the same as the others. Now these 2 have to stay, and these 2 balls are left and right. Each ball direction is the same all the time. No, each ball's motion is the same every time. Each ball motion is the same every time. Each ball direction is the same all the time. One minute. Well, let's try this. Oh, it's okay. The 2 balls on the end move back and forth. The 3 middle balls stay still. This never changes, so each ball motion is the same every time. James and John are playing with a tennis ball. James drops the ball 3 times from different heights. He notices that each time that he bounces the ball to a new height, he bounces back to a new height. So that means when it comes, it bounces back, but it bounces on a new height. Like Jack threw it from height G, then he threw the ball, it came here, and when it came up, it landed on somewhere almost between height E and height F. The following table shows how high the ball bounced each time it dropped. Starting height F, F. bounce height between D and E. That means they started from F, then the bouncing height is E and D. When they between E and D, they came back. The ball came back when it bounced. E between C and D, that means from E it started, the starting point, then it bounced, and when it came back, it was between C and D. And then when they started from D, it bounced and it landed between B and C. What is the height will the ball probably bounce if it drops from the height G? Hmm. From F it dropped and it landed between D and E. So maybe if it drops from G, it'll land between F and E. Or maybe we can say E and F. There. Well done. Direction. Select any of the correct entry in the table. Andy and her friends are playing basketball. They each hit the ball different distance shown in the table below. If each child hit the ball from the same place, who most likely hit the ball with the greatest force? If each child hit the ball at the same place, who most? Okay, so Andy hit the ball and the distance was 10 meter. Ginny hit the ball 21 meter. Susan hit the ball, it was 16 meter, and Mike hit the ball, it was 8 meter. So I think Jill, because more distance means more force, it applies. The image below shows a toy truck rolling down a slope from position A. When it reaches the bottom of the slope, it travels a short distance on a flat surface and stops at position Z. The truck is rolled down the slope again, but this time it started rolling down from the position C. It reaches the bottom of the slope, travels a short distance, the flat surface, and stops at position X. If the toy truck rolled down the slope from B, where most likely would it stop? Near position Y. Sorry, I clicked X. So now it'll go down the slope, but now from A it has the most power while it's going down the slope, because it gets more strength. Like when it goes down, it like gets more push, and then from more push it goes more forward. Now from B it'll get a little less push, so it'll go a little less forward but more than C. C went to X, so B will go near to position Y. But X and Y have a big difference. That's right here. Got it! Kyle and John are both pushing the same box. Kyle is pushing to the right, John is pushing to the left. If the box will not move, if Kyle pushes the box with more force than John, if Kyle pushes the box with more force than John, then it will move the way John is on. That means it will move to the right. John pushes the box with more force than Kyle, then it will move to the left because Kyle is not pushing enough. John and Kyle push the box with the same amount of force. If they push the box with the same amount of force, it stays still. So it is correct. Kyle stops pushing the box, but John does not. Then Kyle won't put any force, and then John will easily carry it through. Bravo! A soccer ball is at the rest of the center of the field. If Julia kicks the ball to the right with a large force, what will happen to the ball? The ball will begin to move to the right because the direction was the right, and it started move. Because of Julia's force, it was more than the force that from the other side. There was actually no force, so Julia will kick the ball far away. Bravo. Next question. As Darren is moving on the grass on his lawn, the lawn mower is moving forward. Place the correct arrow in the box to show the direction of the force moving in of the lawn mower. If we put this here, the lawn mower will be moving this way. But Kyle is not pushing that way, so this can't be it. If it is here, then Kyle is pushing this way only, so it must be the way. But let's check the other options also. Now he is pushing this way, but the arrow saying it's up, so wrong. And if he pushes here, I think it's opposite because he's leaning this way. There's no force over here, so it can't be this. So we got an answer. Got it. An object is moving in a straight line. If an unbalanced force acts on the object, what will happen to the object motion? The object could stop moving completely. No, if it was unbalanced, that means it will be more or less. More or less. The object stop moving completely. No, the object could continue moving in the straight line. That could happen. The object could be. These two might happen. If the force is big, the object will move on in the opposite direction. If the force is small, it will move in the object could continue moving in a straight line. Yeah. But if it's unbalanced, it's already moving. If an unbalanced force acts on the moving object, the object could continue moving in a straight line, begin moving in the opposite direction, or stop moving completely. The object's motion depends on the speed and direction of the force.